Hello, this is a video on units in dimensional analysis. Now units are very, very important. Without a unit, a quantity is basically meaningless a lot of the time. So if you say something is 12 long, what does that mean? Is it 12 inches? Is it 12 centimeters? Is it 12 kilometers? So units are very important. You need them to understand what things mean. You can also use units to understand if you did a problem correctly, or at least to give you a pretty good idea of whether you did a problem correctly. So let's say that a car is moving at 30 meters per second. You can say its velocity is 30 meters per second. And let's say it travels at this speed, at a constant speed, for 2 seconds. And we want to figure out how far it went. Well, let's say you're thinking about this and you can say distance. I remember distance equation is velocity divided by time. 30 meters per second divided by 2 seconds. You end up getting 15. And then you look at the units. And if you did this question correctly, the units should work out. In this case, you have a meter up top. But it's a meter per second and another second in the bottom, so the units end up being 15 meters per second squared. And this is a distance. Well, distance isn't measured in meters per second squared. Clearly there's something wrong with this. So you take a look back and you realize, oh, I made a mistake. Distance isn't velocity divided by time. Distance is velocity times time. So 30 meters per second times 2 seconds. Now you get 60 meters, and you look, meters per second times seconds, those seconds cancel each other out. So your answer is 60 meters. And the units make sense. So you probably did it right. That's a good sign. This is one of the more important reasons you want to use units, is to make sure that you did the work correctly. And if not, you can go back and try to figure out what you did wrong. Now, there are lots of different units that we're going to use throughout this course. I'm going to list some of them just so you know. Most of the time, for example, when we measure mass, we're going to use kilograms. We can use other units. I mean, we can use grams, for example. But most of the time that we're going to do things, we're going to use kilograms. When we measure distances, we're going to usually use meters. Sometimes you'll see we'll use centimeters or kilometers or possibly even inches, but most of the time we're going to use meters. I'm going to even show you how to convert from one unit to another unit in a few minutes. When we do speed or velocity, we're going to use meters per second. Now, speed and velocity, I'll explain the difference about those later on in the course. Meters per second, so that it's a distance in a certain amount of time. When we do acceleration, we're going to do meters per second squared. Acceleration is the change in an object's speed over time. So if, for example, it's accelerating at 1 meter per second, squared, that means that its speed is changing by 1 meter per second every second. So meter per second every second gives you meters per second squared. If we're doing force, for example, we're going to use newtons. And I'm just going to use the letter N right now. And it turns out that a newton is the same, actually, as a kilogram meter per second squared. So those are the same units. Technically, you can use either of them. But usually when we do force, we're going to use the letter N to represent newtons. When we do energy, for example, we're going to use joules usually. And we're just going to express that with the letter J. And you'll see other units used throughout too. We'll do power in watts, for example. But these are the most common ones. You want to make sure that you use the right unit for the right quantity, and for that reason, it might be worth memorizing these. Actually, it probably is. I don't ask you to memorize a whole lot in this class, But if you're going to memorize anything, this is probably some of the stuff to memorize. Because it's really easy for students to make mistakes. For example, let's say I ask you to get the weight of something. Well, people might look at this and think kilograms, but weight is not really a mass. It's actually a force. It's due to the force of gravity pulling down on you that causes you to have a weight. And because it's a force, and I'm going to put weight right here, we measure it in newtons. So you want to make sure that you get the right units and understand how units work. So if you calculate an acceleration of an object, for example, and your answer isn't meters per second squared, there's a good chance that you made a mistake someplace. Well, it's almost guaranteed that you made a mistake someplace. Maybe it's just the units, or maybe it's something else. And this brings up the last point of this video lecture, which is changing from one unit to another. And to do this, we're going to use a technique that's called dimensional analysis. And you can see that right there. I would nickname dimensional analysis, in case it helps you, as just multiplying by 1. Actually, I should just put that in quotes. Because in dimensional analysis, all you're doing is you're taking a quantity and you're multiplying it by the number 1. And not strictly by the number 1, but by a ratio that equals 1. And I'm going to show you how this works. So let's say, for example, we know that there are 1,000 meters in a kilometer. If you take this equation right here and divide both sides by 1,000 meters, what you end up getting is 1,000 meters divided by 1,000 meters is 1. We know that. And 1 kilometer there divided by 1,000 meters. So it's this equation, just dividing both sides by 1,000. So right now you have a ratio, a fraction here, that's equal to the number 1, and that's 1 kilometer divided by 1,000 meters. So because the top is equal to the bottom, even though the units are different, because the top is equal to the bottom, that means that dividing one by the other equals the number 1. So this is actually going to be the same as 1,000 meters divided by 1 kilometer. Both of them are equal to the number 1. So let's say that we're going to need to find a distance. And that distance is 8,000 meters, but we want to find it in kilometers. Maybe you can do this in your head. Then you can just remember that, 1,000 meters is equal to 1 kilometer, and change that form in your head. But it's really, really common for people to make a mistake and just do it the wrong way. It's just a simple mistake, but you end up getting the wrong number. Well, you can double check or even do this conversion with dimensional analysis to make sure you got it right. So 8,000 meters, and we want to multiply it by a fraction that gives us an answer in kilometers. In order to do that, that fraction has got to have kilometers on the top and meters on the bottom. Because when you have meters on the bottom, this will cancel out that. So we're going to look back at this equation here. We want to figure out which one of these gives us kilometers on the top and meters on the bottom. And it's that one. So you say 1 kilometer equals 1,000 meters. So this just becomes 8,000 times 1 divided by 1,000. And the only unit that's left is kilometers. So you end up getting 8 kilometers. Let's say you did it incorrectly. You did it incorrectly. Maybe you put in 8,000 meters times 1,000 meters divided by 1 kilometer. And you get 8,000 times 1,000. That would be 8 million. And now we've got to figure out units. Well, the meters times a meter divided by a kilometer gives you meters squared per kilometer. So technically, 8 million meters squared per kilometer is the same as this. It's the same quantity. Not like this is an incorrect answer, but it's really confusing, and to most people this is not going to make a whole lot of sense. And the fact that the units aren't what we want them to be, they're not kilometers, that's a sign that we did this wrong or incorrectly. So if you just do this in your head and you get 8 million, you might think you did it correctly, but if you actually look at the units, you'll see that you didn't. Let's look at one more complicated problem. And for this one, let's say that there's a car going at 30 meters per second. And we want to find out how fast that is in kilometers per hour. And we can do that with dimensional analysis. So we say 30 meters per second, and we've got to multiply that not just actually by one ratio, but by multiple ratios to get the correct answer in kilometers per hour. So we already know how to change meters to kilometers. We know that we need something with kilometers up top, meters on the bottom, so that this can cancel out that. And so we put our ratio in here, 1 kilometer equals 1,000 meters. So that corrects the numerator right there. But then we have to change seconds to hours, so we're going to need to create another ratio that is equal to the number 1. And because this is on the bottom, that means that we're going to need hours on the bottom as well. So ideally you would have something that had seconds and hours. Well, maybe you don't know that off the top of your head, but you can do it seconds and minutes. And then another ratio here that goes minutes and hours. And we know that 60 seconds is equal to 1 minute. And 60 minutes is equal to 1 hour. So then we put this in here, seconds to minutes, minutes to hours. 60 seconds is 1 minute. 60 minutes is 1 hour. And even before I do all the mathematical calculations, I can check the units. Meters cancels meters. That seconds cancels this second. That minute cancels this minute. So you're left with units that are kilometers per hour. Means we probably did it right, right? 30 times 1 kilometer divided by 1,000 times, times 60 times 60. You can punch this into your calculator. I also want to encourage you to try problems in your head. That's what I do most of the time. So you end up getting 30 divided by hours here. 1 hour. So you end up getting 30 times 3,600 divided by 1,000 kilometers per hour. 1,000 into 3,600 is just 30 times 3.6. And then, maybe you can do this in your head, 3.6 times 30. You want to just do 3.6 times 3. You get 18, 9, 10. And then you got to multiply that by another 10 for 30, so 1080. So you end up getting 1080 kilometers per hour. And there it is, dimensional analysis. Just multiplying by 1. It's actually a much easier technique than you'd realize. It's the end of the video. Thank you.